Hello guys, hope you're doing well. In this class we will continue about our talk about sequences and series. As we have been talking about the sequences, we said that we have two main types of sequences: the arithmetic one, the geometric sequences. So in this case, while we have arithmetic sequences, we said that if we want to move from one term to another one, we have to add one constant. We call this constant d. While the case in geometric sequences, we have to multiply this preceding term by a constant, which is in this case r. So we call this geometric sequence, we call this arithmetic sequence. And we said that we have two main formulas for each one of these sequences. The first one gives us the nth term of this sequence because it's an finite sequence. The second formula gives us the sum of terms until nth term. So we have an for the arithmetic sequences. An can be written as a1 plus n minus 1 multiplied by d, and as we said, d is the constant to move from one term to another. Sn equals n over 2 a1, which is the first term, plus an. While the case for the geometric sequences is a little bit different, we have another two formulas. An in this case, it's the first term a1 multiplied by r, which is again the constants between two terms multiplied to the power n minus 1, and the summation of terms equals to a1 1 minus r to power n over 1 minus r. So guys, we have to memorize these two formulas for each one of these types of sequences. Geometric means multiplications, arithmetic means addition between these two terms. Guys, we have to notice that in all these cases, the summation of terms or the sum of these terms are finite. So we have a1 and we have an. So basically I'm just adding the terms between a1 and an, a1 and an. The same goes for geometric sequence. We have a finite sequence. So I'm adding from a1 until the nth term in this case. But we have a special case when we have infinite number of sequences or of terms. How we can find the sum, or how can we find the nth term in this case? Let's have a look. Guys, let's take a look at these infinite series. So here the first one, which is 1, 4, 7, 10, 13. We can notice that if you want to move from this term to this one, you have to add 3. Again, you have to add 3, which is d in this case. So this is an arithmetic sequences. But still I cannot find the last term, because in this case we have infinite number of sequences of terms. So how to find the sum of this while I have infinite number of terms? So basically in this case immediately I would say that I have no sum, or the summation of these terms are infinity. So there's no need even to use the formula, because I don't have an and I don't have an specific number for this summation. I have infinite number or infinity for the summation of this infinite arithmetic sequence. While the old cases, when we have finite, so in case we have finite arithmetic sequence, as we said, we have a1, the first term, and we have the nth term, in this case 51. So to find the sum or to find the summation of these terms, immediately we would use the formula that we've seen in the last two classes. Sn equals to n over 2, the first one plus the last one. or we can use this formula because an is n minus 1 over 2 plus multiplied by d. So basically you have the formula when it's infinite arithmetic sequence. Again guys, we are speaking about arithmetic sequences, infinite or finite arithmetic sequences. Let's take a look when we have a geometric sequence instead of arithmetic sequence. 1, 2, 4, and so on. So basically I'm multiplying each one of these terms by 2 to get the other one. When we have a finite geometric sequence, immediately I can use the formula. Formula is n equals a1 1 minus r to power n over 1 minus r. So this is the way to find the summation when we have finite geometric sequence. While in this case, or in the case when we have infinite number of terms, what should I do? So guys, here we have to distinguish between two cases. The first one, when we have r, which is in this case 2, because I'm multiplying by 2, the r, the constant, which allows me to move from one term to another, I have to distinguish two cases. The first one is when r is bigger or equal to 1. The second one is r, or the absolute value of r, is less than 1. So in the case where the absolute value of r is bigger or equals to 1, we would say we have no sum, or infinity, or infinite sum. So we don't have a specific number. So immediately I would say no sum, as the case with the infinite arithmetic sequences. The second case, when we have this r, or the absolute value of r, is less than 1, so immediately I would say the infinite sum of this series is a1 over 1 minus r. Why? Because if we want to prove this, we can prove this, guys. We have a mathematical way to prove that the infinite sum of this geometric sequences with this r is equals to a1, the first term, over 1 minus r. So 4 cases, 2 cases for arithmetic and 2 cases for geometric. We have no summations for infinite arithmetic, while when we have finite arithmetic we have the formula. Again, for the geometric sequences, when we have the finite number of terms, we can use the formula. When we have infinite number, we can distinguish between two cases, whether the absolute value of r is bigger than 1 or less than 1. So we can use this formula. Okay, yes, we have to memorize these formula because sometimes I'm asked to find the sum, or the first term, or the nth term of this series, and I have to pay attention whether this series is a finite one or infinite one. Let's try to look at one of these examples. Okay guys, in this example is asking me to find the sum if possible. This means if we have a specific number, because sometimes, as we said, the summation is infinite number or infinity. So how to find the sum of these numbers? 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 and so on. So basically guys, the terms in this case is the first one is 1, the second one is 1 over 2, the third one is 1 over 4 and 1 over 8. So how would I know that this is an arithmetic or geometric sequences? I have to look at these two terms. Example, look at this one and look at this 2. Look at this 2 and this 4. If you want to move from this 2 to this 1 over 4, so basically you have to multiply by 1 over 2. If you want to move from this 1 over 4 to 1 over 8, you have to multiply by 1 over 2. So this is a geometric sequences with the constant or the multiplying constant is r, which equals to 1 over 2. You take one of these terms, you divide by the other, you get this constant. Okay, so now I'm asking myself the question, is the absolute value of this r less than 1 or bigger than 1? Yes, it's less than 1. Because it's 1 over 2, yes, the absolute value is less than 1. So yes, I do have a sum of this geometric sequences. How to find it? I have to get back to this formula. Yes, I do have r is less than 1. So I can use s equals a1 over 1 minus r. This is the formula which gives me the summation of this sequences. So s a1 over 1 minus r, in this case a1 is 1 and r is 1 over 2. So the infinite summation of this geometric sequences is 2. So if you want to add all these numbers until infinity, you will get the answer will be 2. Thank you guys, hope you enjoyed the class.